This video covers Trig P.8 and Pre-Calc 1.7. This is going to be part 1 of the video, and what we're going to be doing is piggybacking off of the last concept we talked about, which was graphing parent functions, and we're going to now start to make some transformations. So we're going to talk about horizontal and vertical shifts, so moving the graph left and right. We're going to talk about reflections, so reflecting along the x or y axis, and non-rigid transformations means shrinking or expanding the graphs. Okay, so what I've done here, and if you have three different colors, so a pen, a pencil, and a highlighter or something, you want to do your notes in 3 different colors and try to use the 3 colors that I'm going to use. For my notes, I'm going to use red, blue, and kind of a pinkish color here, or purple. So pay attention to the fact that first thing I'm going to ask you to do is to graph these 3 equations. Okay, so graph the parent function, and I've done that in red here. So this is the x squared graph in red. Then I graphed the x squared function plus 2, and that was the pink graph, so x squared plus 2. And then I graphed x squared minus 2, and that's the blue graph. So I'm going to invite you to pause the video and graph these 3 graphs on your xy axis, but make sure you're putting all 3 on the same xy axis. Okay, so once you've done that, what has happened as we moved from our parent function to basically our parent function plus 2 and our parent function minus 2? Well, notice that all that's happened is our intercept has either gone up 2 or it's gone down 2. So when we take a look at from the f function to the g function, from x squared to x squared plus 2, notice that when we added 2, that shifted it up 2. When I went from x squared to x squared minus 2, so when I went from red to blue, the graph, the intercept has moved down 2. So this has shifted the graph down 2. So what we can now say is that when we add or subtract a number to the end of our equation, or of our parent function, in this case parent function being the x squared, when we add or subtract, that's going to either shift our graph up and down. So that's going to be a vertical shift. If it's positive, it moves up. If it's negative, it moves down. Okay? So you should now be able to look at an equation and recognize that if it's x squared, it's going to be a parabola. If I add a number to the end of that, I'm going to move it up. If I subtract a number to the end of it, I'm going to move it down. You don't necessarily need to put these into the graphing calculator anymore. Alright, taking a look at our next example, I'm going to ask you to graph the parent function of x to the third, so that's my red graph here. And I'm going to write an x to the third next to that. And I'm going to ask you to graph an x plus 3 raised to the third power minus 1. And that's the graph that I've graphed in this pink color. So x plus 3 cubed minus 1. So again, pause the video if you would please, and take the time to draw these graphs on your x and y axis. Okay, so once you've done that, what has happened to my graph? So the easiest way to do this is to look at the intercept. So the intercept is here at 0, 0 for my parent function, which we discussed the other day, and now it's moved to over here. So notice what's happened is that I've shifted to the left 1, 2, 3, and I've shifted down 1. Well, what numbers in my problem tell me that? Well, when I put a plus 3 right here, notice that the plus 3 moved my graph to the left. And you may say, well, it's plus 3, it should move it to the right. So what's going to happen is the number that we add or subtract to the x before we take the parent function, in this case the parent function is the cubed, is going to move it opposite direction. And that's going to be a huge concept to understand, is that's going to be the confusing part, is you're going to see a plus 3 and say, oh, it's going to move it right 3. But it actually moves it left 3. The other thing is this 1 right here. Notice that the graph has been shifted down. So just like when we did a minus 2 over here after the parent function, so we've got the x to the third and then we subtract a 1 from that, that's going to move it down 1. So that's going to go in the direction of the sign. If it's a minus, it's going to go down. If it's a plus, it's going to go up. But when your number is inside of the parentheses before you raise it to the power function, in this case the third power, it's going to move in opposite direction. The whole goal that I'd like to see from you is that if I give you this equation without you putting it in the graphing calculator, I want you to tell me exactly what these do. Okay, the next example, we're going to start talking about how we can identify which type of reflection is going to happen in our graph. So the red graph is an x squared graph, and so that's the parent function, and the pink graph is negative x squared. So again, pause the video, take some time to plot these two graphs in your notes, and then play it back so we can finish this example. So if I'm asking you what happens to the graph in this example, we can see from our graph that the red graph is opening above the x-axis and the pink graph is opening below the x-axis. In other words, if I was to fold the red graph down along this axis here, the x-axis, then it would overlap on top of the pink one. So that's going to be a x-axis reflection. Okay, so when we see this minus sign right here with our parent function, then that is going to be an x-axis reflection. Okay, continuing with the concept of a reflection. So we said before, when we had the when the negative was with the parent function, that it's going to make a reflection along the x-axis. Now what I want to do is take a look at three different graphs here. We're going to talk about changing our parent function to the square root of x. So that's what the the red graph is, square root of x. The pink graph is the negative square root of x, and the blue graph is the square root of negative x. Okay. So again, I invite you to pause the video and to draw these three graphs all on the same axis, please. And again, please do them in different colors so they pop out in your notes. And then let's play the video and discuss the reflections that were made. Okay, so what has happened to our graph? First of all, let's just compare from F to the G graph. In other words, when I have the parent function and then I take the negative of the parent function. You'll notice that that was an x-axis reflection. So again, you notice that the red one is above, the pink one is below, so if I fold it along the x-axis here, the red is going to overlap on top of the pink. Okay, so that's no different from the previous example that we did, it's just a different shape because of a different parent function. On the other hand, if we now look at what is happening from the parent function f to the h graph, which is the negative square root, the square root of negative x, notice that now the reflection has changed. It's now being reflected along the y-axis. So if I was to fold the graph along this y-axis, this pink or this red graph would be where the blue graph is. So it is a y-axis reflection. So it's very clear from the graphs what the reflection is, but how do you know what the reflection is without taking a look at the graph? So if the negative sign is outside of the parent function, in this case the parent function is the square root of x, so if the negative is outside, it's going to be the x-axis reflection. If the negative sign like this one is inside the parent function, I'm going to abbreviate here, like this one, then it's going to be the y-axis reflection. So just by changing the placement of the negative sign to outside of the square root or underneath the square root, it's going to change it from a x or a y-axis reflection. You need to know how that placement of the negative will affect the graph. Alright, taking a look at our next two equations that we're going to graph. I actually want to do this a little bit backwards from how we've been doing it. We've looked at the graph, and then from the graph we've drawn a conclusion about what has happened to our graphs. What I'd like to do is I'd like to actually use what we learned about the placement of certain things, for example, the role that this negative will have and the role that this plus 2 will have, and then see if we can verify it by looking at the graph. So here's what I know. When the negative sign is outside of the parent function, that's going to be a reflection along the y-axis. I'm sorry, not y-axis, x-axis. I was thinking x, but I said y. So it's a reflection along the x-axis. When I put a 2 inside of the parent function, so because the square root was really, we're taking the square root of all of this, that's going to shift it opposite direction of the sign, right or left. So in this case, if it's a plus 2, I would assume it's right, but it's opposite direction. It would make a left shift of 2. So let's actually graph these and then see if, based upon what we assume the graph would look like, if our graph is going to look like what the graphing calculator will show us. So I know that a square root of x has a y-intercept at 0, 0, and then it goes off in this direction like so. So that's this graph. Now, putting these shifts here, let's first do our shift of left 2. So the intercept is going to move left 2, and instead of going up, it's going to have a x-axis reflection, so my graph is going to go downward. So my graph should look like that. So now let's verify this by looking at the graphing calculator and seeing if we're getting those equations. And we can see when we look at the graph that our graphs do look like we assume they would look from the shifts that we know. Okay, so I want you to rely less on the graphing calculator to show you what the graph looks like, and more based upon what you know now about the shifts. We know that that's a x-axis reflection. We know this is going to move it left 2, so let's do that. Move the red graph left 2 and reflect it, and you're going to get the blue graph.